Good morning, guys. Monday again, so we're here for a weekly video. I hope you had an awesome weekend. And this is week 6, right? So I'm gonna start by addressing a couple of issues, especially about LO8. LO9 was pretty good. I don't have any, I didn't see any issues. And most of the issues I saw in LO8 are because of me, and I'll explain in a little bit. And then after we address this, we'll go over what we have for next week and remind everybody that we're going for the chapter 10 and 11, veracity of data, and then the animal research and its unique features. So what is due for Sunday is LO10 and LO11. Sorry, still sick. Now, LO8. If you go to page 151, it's pretty clear in our book, and it says bias is inherently limited when the measure of the DV is objective. So when we know, for example, that we are measuring bone density through DEXA, okay, and you know DEXA now is a gold criterion of bone density. If we have the ability, if we have DEXA, the DEXA scan, and if we have the ability to include that in our research, then inherently bias is limited. So that's the way we're protecting ourselves, because the measurement we know already by a ton of research out there that it is objective. So page 151 for that. Another issue in LO8, and a couple of you sent me emails and wanted me to explain that the relationship between internal and external validity, and it's inverse. You can find that in our book, page 144. What does that mean? It means that, let's say, for example, we do research in the lab, right? If we do research in the lab, we have higher internal validity because we can control for everything. The temperature, for example, of the room, and the light of the room, and we can control for way more variables than if we were doing the same thing outside in the field. Now, the more we control variables, the higher the internal validity. Okay, but the higher the internal validity, that makes it not very real life research. So then the lower the external validity. If we do the same research outside and the sun is snowing, there's wind and this and that, then it's more real life situation. So that increases the external validity, which means we can extrapolate more our results to real life situations. But then we're going to lose in internal validity. So it's a binary system. It's a dichotomy, as our book says. If one is high, the other one has to be low. So we need to choose what's best for what we are investigating. I hope that makes sense. If it doesn't, again, page 144, also email me your questions again. I'll try to explain better. Now, there are three things in LO8, and I fixed it. One was about when measuring, we have to have we have to be getting the same results again and again, which means the variable has to be reliable. So I changed that. Sometimes mistakes happen as teaching assistants upload the question. So I changed that. Whoever said reliable got the point. And a similar event with another question that had to do with the variable being valid. So I fixed that too, and whoever said valid got the point. And then the last one, it talked about that it was a typo. Instead of false variable, it should have been surrogate variable. So I changed the wording, and then I gave everybody the point because that's on me at the end of the day. So everybody got the points for that last item. And again, I don't necessarily care about grades so much, and I hope you don't either. I care more about feeling safe and inclusive and learning more. Okay, that's all for feedback wise. I'll go ahead and talk about the two chapters we're covering this week. So chapter 10, veracity of data. Okay, can we trust the data? We need to be very, very thorough before we answer that question. In order to answer that question, we usually go, we're using two ways, the validity and the reliability. Let's start with validity, okay? There are many definitions. Our book has some in there as the chapter starts, but the idea is, does that test measure what we want to measure? Does it? If it does, it has high validity. We're going to talk about three types that have to do with that. Okay, well let's start with content validity, and then we have criterion validity, and the last one is construct validity. I'm not going to try to confuse you. Some things may sound very technical, but the more you understand now, the more you're going to understand research as you're reading it, or flaws of research as you're reading it, and also how you can make your project even better. So content validity, the extent to which a measure represents all dimensions of a given construct. All right, and because one construct may have a lot of dimensions, does that uh, whatever we weigh have to measure that, do we capture all of those? That's the content validity. Criterion validity is when we're comparing whatever we're measuring our results with a gold standard, right? In order to do that, our book says very nicely that we use regression. We can have two or more variables, and we get correlation. And I hope you know what correlation is. Okay, it's a relationship, interrelationship between two or more variables, right? Um, let's talk about two variables. And it's not a statistics class, but hopefully you know that it goes from -1 to 1. 0 means no relationship, -1 is perfectly negative, and +1 is perfectly positive, which means if it's positive, that for example, if one goes up, the other one goes up as well, right? The bland outline is a visual representation uh, of how well the two methods that we may use agree. It's not affected by range, but it helps us understand the clinical importance of the findings. Now, how can we investigate criterion validity? We have concurrent validity and predictive validity. Concurrent validity is examining an instrument by administering something else, some other criterion that we chose at the same time and comparing the results. Predictive is we get our data, but we're trying to predict some later behavior successfully, hopefully. And then that's how we create prediction formulas, but we need always to check through cross-validation if that's something that is successful or not. And the last type of validity is the construct validity, is the test that measures the construct it intended to measure. Okay, those are the three types of validity. So we talked about the general definition and then how we can break it down. Now, which are the factors that could affect the validity of our data? First of all, is which criteria are we going to use? You want to measure body fat. Are you going to do hydrostatic? Are you going to do bot pod? Are you going to do calipers? Are you going to use DEXA? Are you going to just use waist to hip ratio? How are you going to... So the choice of that measure and the error or the objectivity of those results really affects your validity. Population, demographics, right? What are you going to use? Athletes, non-athletes, ages. Are you going to have any restrictions? Are they going to be taking some meds or not? right? What's the training experience, height, weight, everything can affect that. And then objectivity, we need to interpret the results uh, based on some standardized measurement tools. So the results, for example, of BMI have to be compared to normative data that we know. So my BMI has to be compared to my age group and race and gender in order to identify if I'm normal, below normal, and so on and so forth. So all this affect validity. Now, let's go to reliability. So it has to do with if a measure can be repeated and we get, if not the same, very similar results. It's a prereq of validity. So in order to have um, something to be reliable, has to be valid, but a test can be reliable but not valid. For example, we have scale, and that scale is off by 2 kilos, but whenever we get on that scale, we get results that they're similar results, right? So we repeat the same test again and again, and we get similar results. But overall, the scale is 2 kilos off. So this would be reliable, but it would not be valid because it wouldn't actually show us our actual weight. Hope that makes sense. Another thing I have to talk about in reliability is measurement error. We're trying to reduce that as much as possible. It has to do with the participant, the testing, the equipment, the scoring that we're using, and so on and so forth. Now we go a little bit into Texas, just a little bit. So we have now different kind of correlation, ICC, intra-class correlation, and then we have SEM, standard error of measurement. Those tests help us interpret the reliability of the test. Now, there are some methods in stats that help us establish if something is reliable. Have that test, retest reliability. So are the scores consistent over time? And when we have one scorer, for example, I give you a questionnaire about mental toughness, and then I give you again a question about mental toughness. Are these scores consistent over time? So there we have intra-rater reliability. Now, if I have different people scoring the same thing, so I have you assessing your levels of mental toughness, I have your coach assessing your mental toughness, I have your strength and conditioning coach assessing your mental toughness, your athletic trainer, and so on and so forth, then we're looking for inter-rater reliability, right? So people or different measures assessing the same thing, and we're trying to see there if the inter-rater reliability is high or low. Now, reproducibility. Replicating studies is very helpful in order to see if a theory about something is applicable into, let's say, different demographics or different settings or times. Although some people don't like replicating the same studies, they're really helpful to see if something can be reproduced in different kinds of, as I said, settings, time, or samples. The second thing that we can use as a method to establish reliability is equivalent or alternate forms reliability. So we have identical tests, but we change a little bit the wording of, let's say, of the item, as I was giving you the kind of same mental toughness questionnaire that have the same number of items, that are addressing the same key dimensions of mental toughness, but I changed a little bit the wording to see if it actually captures what I thought it would capture, and if that's consistent over time. Internal consistency reliability, we may have multiple assessments within a day, right? So that can be anything, let's say a dynamometer of your hand grip strength, and you do it again and again in the same day or the same testing day or the same session, trying again to see if the numbers I'm getting are consistent. The chapter ends with suggestions for research design, and those are some suggestions that I would like you, as you're reading them, to think about your own project. Talks about designing the experiment, gathering the data, analyzing and interpreting the results. So as you're reading those, please think about your experiment. We're like 2 weeks out from spring break, and I will make a specific video at some point about FLO. Just start thinking about it though. And I know I've answered a lot of questions via emails to some of you. Anyway, check again the glossary and understand how we can increase the veracity of our data and how thorough we need to be um, when we're trying to figure out if they are reliable and valid. Chapter 11 talks about animal research, right? It talks about, it's very well known, the Harvard Fatigue Laboratory, and still our research mainly involves humans, but animals are used too for several reasons, such as logistical reasons, level of danger for humans, or when our research is about animals, right? So in biomedical research, very popular. It's been a long time they've been using animals. You can see that in table 11.1 how animals have helped us discover a lot of cool stuff, right? Now FDA made it mandatory to make sure that whatever has to do with food additives, cosmetic drugs, and all these kind of things to be tested in animals before humans. Now, of course, the animal well-being issue was brought up at some point, right? And then we had the Animal Welfare Act that included the acceptable standards for this kind of research, and then we have the Guide for the Care and Use of Laboratory Animals. We use more animals in the 21st century, mainly, you'll see that in our book, The Human Genome Project. That was really important. And we use more animals specifically because that was boosted through that project, in more particular mice and zebrafish. Okay, now how are we going to select the species? Of course, we need species that resemble humans, so we need a lot of times to use mammals, but non-mammalians are used too, such as the fruit fly and the squid, for other reasons I explain in our book. Now, when we come into exercise science, do we use animals? Yes, we do, but approval is necessary. Why? Because, of course, animals cannot consent. So the proposal goes to IACUC, and we need, when we do research with animals, demonstrate, as our book nicely says, the 3 R's. Reduction, we are using as few animals as possible, and that has to do with the statistical power. We talked about the statistical power. Refinement, what are we doing to eliminate stress or pain to those animals? And then replacement, that this is the best method we could design based on our research question and the results we're going to get out of this. Okay. Now, in exercise science, we're looking for models of increased and sometimes decreased physical activity. Rats are very popular. There's a lot of research with rats that have to do with exercise and body weight and insulin resistance. We like them because of aging and how much it takes them to age, and we see the results of aging in them. In most cases, when cardio is involved, of course, running is preferred. Swimming has been an option, but in any case, safety of the animals is number one priority. Now, when we talk about resistance training, is really hard to emulate resistance training, as you understand, with animals. There have been efforts to make them do some kind of resistance training, but that's not easy. Now, we're interested in changes that happen in the animals when physical activity is reduced or stopped. So there have been examples of immobilization, like the hind limb suspension, as you will see in our book. And in table 11.2, you can see in general it's a great table puts together a lot of information about the advantages and the disadvantages to using animals in research. Now, when we talk about large animals, we have horses that are held with cardiorespiratory research. We have pigs, cardiac surgery, very well known, right? Dogs, cancer, for example, COPD, etc. Cats, nervous system. And our book talks about a very popular um, experiment that I use it when I'm teaching analyzing human movement this semester. And monkeys and apes are very, 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 very similar to humans, but the most resistance we get about using this kind of large animals is about monkeys and apes. But in any case, we need to understand that these animals, whether they're coming from the US or another country to the US, they're bred specifically for this kind of research. For this chapter, understand how animal research has played a vital role in biomedical research and exercise research, right? Understand the restrictions, and understand that we still need them. So we need to use animals in our research, but we still need to make it as safe as possible. Check the glossary again and let me know if you have any questions or concerns. Have a great week, guys, and in the meantime, live intentionally, not habitually.